I've started the recording.
Yeah, I just wanted to confirm, like, am I audible properly to everyone?
Yeah, you are audible.
Okay, fine. So, we'll start the class, and it's about number 3, and I'm Shresth. I'm a member of Sufi and OMC. If you must have you might be knowing about Sufi as well. So, uh, let's start. So, I just wanted to ask everyone: is everyone familiar with like number, natural numbers, and all of that, like the notations? Okay, fine. So, uh, how much? How like does everyone know Euler totient function?
Yes.
Okay, fine. So yeah, we'll start. So we'll first do a few introductory problems, and then we'll jump into the intermediate and then the advanced problems. Okay, I'll be sharing my screen. Yeah, is my screen visible? Can someone please confirm?
Yeah, it's visible.
So, so the first problem is about greatest integer function. So, is everyone familiar with the greatest integer function?
Yes.
So, how like I'll give some time for you all to try the first two problems, and if anyone has any ideas. Also, I'll request everyone to mute themselves so that there's no like disturbance or cross. You can either put it on chat or yeah, any ideas on the problem? Like any two problems. It's not necessary you have to first attempt the first one and the second one. Anyone? Uh, Oh, so I just write a few uh, like is it fine if I give a hint, a small hint?
Yes, ma'am.
Actually, I'm not very older than y'all, and I'm a boy as well, so I'm not. So you can refer me as Shresth. It's fine. Okay, so I'll give a hint. So the hint is that I think everyone's familiar with greatest integer function. So greatest integer function is like, for example, 3.14, like pi, or 3 point, no, not pi, 3.14 will go to 3, and -1 will go to -1. But -1.5 will go to -2, and stuff like that. So the smallest integer, that is like the integer, largest integers that are smaller than the number itself. That is what is GIF. So if I let GIF of square root of n, if I let that to be k, then I can say that this number is less than square root of n, right? And k is less than square root of n, because less than equal to, in fact, because n can be a perfect, like root n can be an integer as well. So I can write n equal to k square plus l, right? Because n also is greater than k square. So I can write n. So 1 second. I can write. Can do we have a bound on L? Um, Hello. Anyone? I'm audible, right? Acha, Martin has answered. Oh, I can't see chat actually. Anyways, so bound on L. So Martin said that 0 is less than equal to L is less than equal to 2k. Very good. And moreover, what I have is the condition basically is that k square plus 2 divides n square plus 1, right? Okay. Now, can you get a bound on um like what is a good bound? Wait, first of all, what you do is that you can just substitute n as k square plus L, and then we can get a bound. Yeah, fine. So original condition. Come with this. Yeah. So substitute n equal to k square plus L to get k square plus 2 divides k to the power 4 plus. Is this fine? Like I can write this, right? Because I substituted n as k square plus L. And now the idea is that, so instead of, so k square is congruent to -2 mod k square plus 2, right? Since k square plus 2. So what I'm doing is, in other words, uh, I'm subtracting, I'm using the fact that k square plus 2 divides k to the power 4 minus 4, and k square plus 2 also divides k square plus 2. So that's what. So if I use the fact use that thing, then what I'll get is that, so basically k square plus 2 divides 4, like k to the power 4, instead of k power 4 I can write 4, right? Similarly, instead of k square I can write -2, so minus 4l plus l square plus 1. So yeah, k square plus 2 divides with k square plus 2 divides l square minus 4l plus 5. I think many people have like joined just now, so we are discussing these two problems. So you can try them, and we are now discussing the solution for the first one. So does everyone follow till here that k square plus 2 divides l square minus 4l plus 5?
Yes.
Okay. So what else can I write? I can write l square minus 4l plus 5 can be written as l minus, like if I had it as l square minus 4l plus 4 plus 1, and l square minus 4l plus 4 is nothing but l minus 2 whole square. So I can write it like that, right? And now I'll ask, what is the bound on l square minus 4l plus 5 upon k square plus 2? Because that is an integer, right? So that is also l is less than equals to 2k. So what can be a bound on this? Sorry? Yeah, Pragyan, what did you say?
Oh, sorry.
Acha, yes. But yeah, it's very simple. So you just use the fact that L is less than equal to 2k. So what can be a bound? So yeah, it's very simple. So basically, that fraction is equals to L minus 2 whole squared plus 1 upon k squared plus 2, right? And since L minus 2, so for L greater than 2, L minus 2 whole square is obviously increasing, right? And if L is less than 2, then so it's obvious. Then it can only be 1 or 4 or 0. So k square plus 2 will have to be, so that those are the boundary cases which we can check later. But I can say that this thing is less than 2k minus, okay fine, I can say this is less than 2k squared plus 1, right? 2k whole squared plus 1 upon k squared plus 2. That is a very weak thing, but it's still helpful for us because this thing is itself is less than 4, right? Because it becomes 4k square plus 1 upon k square plus 2. So that thing is less than 4. So if I assign like if I assign it a variable m equal to the fraction, then m is less than 4. So I can say that m equals either 1, 2 or 3, because m has to be natural, because numerator and denominator both are positive always. So m has to be a natural number, and since it's an integer, it can be only 1, 2 and 3. And after this it's very simple. So if you just take m equal to 1, yeah. So taking so now you just make cases. So like, can anyone help me for m equal to 1? How will I finish? Yeah, hello. Just to confirm, I'm audible, right?
Yes.
Okay, fine. So yeah, so uh, yeah, I think he made a typo. Very good. So we have 1 equal to L minus 2 whole squared minus k squared, which gives, so like, which gives k equal to 0 and L minus 2 equal to plus minus 1. And clearly minus, like, you get L equal to 1 and minus 1. Sorry, 1 and 3. And for both of them, the fact that L minus, one second, someone, yeah. So yeah, so thank you, Martin, for this case. Can you help? Can someone help me with the next case as well? Uh, like, if you want, you can unmute as well. You can unmute and present your proof. Martin, would you like to try m equal to 2? Okay, I guess I'll have to pick a random volunteer from the participants. All right. Harsh Mishra, would you like to present a proof? Harsh Mishra, can you hear me? Yeah, so like, do you have any ideas to tackle the m equal to 2 case? Okay, Harsh, can you unmute your mic? Okay, you'll join some other things. Okay, till the time I'll just start with the proof. So what we get is that L square minus, okay, fine, I'll just write what we get. We'll get L square minus 4L plus 5 equals 2k squared plus 4, which implies,
Yeah, so am I audible?
yeah. Yeah, so do you have any ideas to finish the proof? So this is what you get basically when m equals 2. So how will you take it from here?
The left hand side is odd, and the right hand side is even, which is like not possible.
Okay.
So then L must equal to 0. Is like the only we must have like this is no solution then, right?
But when like the left hand side, why is it always odd?
Oh, sorry, no.
Not all. Yeah, but it's a good
Yeah.
idea. So you have L is odd basically.
Yeah, if L is not, yeah.
Okay, I mean you can write this as like L minus 2 whole squared equals 2k squared plus 3. You can write it like this as well. Huh?
Yes.
Yeah, and what do you know about like a square of an odd number? What is special?
Um they're congruent to 1 modulo 4.
Okay, very good. So it's congruent to 1 mod 4. So the
Yeah.
LHS should be congruent. So the new equation,
Here if we see that the RHS is 2 mod 3, sorry 1 mod 3, so L minus 2 must be an odd number.
no, RHS is, how is it 1 mod 3? This one, right?
Sorry, I mean it's 1 mod 2.
1 mod, yeah, RHS is odd, yeah. So L has to be odd, that is correct. And what Vinayak said, like that's what, how you can finish it. That L minus 2 whole squared is congruent to 1 mod 4. And 2k squared plus 3 is congruent to 1 mod 4. So 2k squared is congruent to 6 mod 8, which is not possible because 2k squared is,
Because then k square will be congruent.
yeah, it's not possible. Yeah, so very nice. So we are done. So here, check mod 4, check mod 4, checking mod 4 works. Okay. Yeah, Vinayak, would you like to do case 3 where m equals 3 and we have L square minus 4L plus 5 equal to 3k squared plus 6, or L square L minus 2
Yeah,
whole square.
I think I've done that.
Okay, how will you do it?
So we again write it as L minus 2 whole square plus 1 is equal to 3k square plus 6.
Hmm.
Then it becomes 3 minus L minus 2 L minus 2 square is equal to 3k square plus 5.
Hmm.
Which we can combine a 3 and write it as 3 into some constant plus 2.
Hmm.
That is 2 mod 3, but we know that any square number can be 0 or 1 mod 3 only.
Yeah, so we can write this as 3 into k square plus 1 plus 2, right?
Yeah.
And we can check mod 3 works. All right, so what does this mean? That there are no solutions to the condition, and that is the correct answer. There are no solutions to the condition. So this problem was a bit stupid because there are no solutions, but it's also very good to learn how to handle with GIF function and mod, bash, all of that. Like mod 3, mod 4, how you can check to give your argument to get better constraints. So yeah. Next problem. So the next problem. So this one was, I think, APMO 2013 problem 1. APM 113 problem 1. And the next problem is Balkan Maths Olympiad 2017 problem 1. Yeah. Here. I think someone posted a solution last night somewhere. I don't remember. Wait. I think it was Krishiv. Is Krishiv in the class? Okay, fine, he's not there. But has anyone else seen the problem?
Yeah, I think I have done that before.
This one, Balkan, you have done, right?
Yeah.
So do you want to try another problem?
Yeah, you can show that.
Okay, fine. I'll share the next two problems, which are the intermediate problems. I'll just a second. And in the meantime, if someone hasn't tried the Balkan problem, they can do that as well. Wait, is my screen visible?
Right now it's not visible.
Acha, okay. Now,
Yeah.
so this is problem 2.2. Yeah, and then so like have everyone noted the Balkan problem if someone's trying that?
Yes.
Okay, fine. So you can try the next two problems if someone hasn't done the Balkan one. And the intermediate problems are actually very interesting as well. So yeah. Also, it's raining. So I'm from Mumbai and it's raining here. So if I lose my connection somewhere, then please ping me on whatever Discord or WhatsApp or basically I might lose connection. Although it shouldn't happen, but I might lose connection. But I think I won't lose it for like more than 2-3 minutes. Yeah, any ideas on any of these three problems? Especially the 2.21, because that's the easier one. Yeah, also who else has seen the 2.2 problem, like the Balkan one? Apart from Harsh. Harsh, if like after some time, like if someone like is it fine if you present your own solution to us for 2.2, or you want to just try at 3.1 and 3.2?
Yeah, like I can tell that how I did it.
Okay, so let's wait for some time, let others try. After that, if you want, then you can tell.
For problem 3.1,
Yeah.
it says that A is greater equal to 2B. Does that mean like A is of the form like 2B plus K? K is a natural number, or A is just one specific value?
Yeah, you can write A as 2B plus K. Yeah.
All right. Okay.
A is basically a constant. Look, I think that's what you meant.
A is a constant,
Yeah,
or like A, or can you take like A as 2B plus 1, 2
yeah,
minus
2B
2,
plus
2
1,
plus 3,
2B
blah,
plus
blah,
2.
blah.
2B also is fine.
Right.
2B is also fine. I mean, obviously, then you can just say take the polynomial as the identity function for 2B. Or, yeah. Also in 3.1, you can just take B greater than 1, because B equal to 1, the case is like dumb. It's like useless. And that in the 3.2, if anyone's trying that, so it's just fine if you tell the permutation itself, for like which permutation you'll get the minimum, because calculating the minimum is like just computation after that, so that is also fine. Okay, so I think I'll start with the problem 2.2. Like I'll give some hints. So x and y are positive integers, right?
Could you just see problem 3.2 for 1 second?
3 point.
3.2.
Okay.
Yeah, I think I might understand.
So you were trying. Wait, is it possible for you to like note down the problem somewhere?
Yeah, I'll just just give me 1 second. I'll just note.
Yeah, fine.
Okay, I think I'll just
Sorry.
yeah, I can start. I
Okay.
think yeah, I can go on.
So yeah. So the Balkan-Nemo problem, x cube plus y cube equals x square plus 42xy plus y square. See, the problem is that the left hand side has degree 3 and right hand side has degree 2. So a good way to handle this is like kind of reduce the degrees into something which is manageable. For example, if I just let the greatest common divisor. So I hope everyone's familiar with GCD, how to work with that, right?
Yes.
Yeah, go fine. So if I just take GCD of x comma y to be d, so I can write x equal to dA and y equal to dB, right? Where a and b are co-prime.
Yes, I think so.
So what's left is basically, so I just substitute this into the equations. I get d cube. So x cube plus y cube is just d cube times a cube plus b cube, and that is equals to d squared times a squared plus ab plus b squared. So 42ab. Yeah. So I can just write a d here. Okay. It's fine till here.
Yes.
Okay. And then I can write a cube plus b cube as a plus b times a squared minus ab plus b squared. So if we just rearrange it a bit, then so what I'll do is I can write now a squared plus 42 ab plus b squared can be written as a squared minus ab plus b squared plus 43 ab. So there are two advantages of writing this. So basically what I want is because after this I can write dA plus dB minus 1 times a squared minus ab plus b squared. So I'm taking a squared plus ab minus ab plus b squared common. I can write this as 43ab, and the advantage is that 43 is a prime.
We can just have two cases, that when a square minus ab plus b square is 1 and when it is 43.
Yeah. Very good. See, and why is that true? Why can we have that? Because a square minus ab plus b square is co-prime with
a and b.
Is co-prime with a and b, because a and b are co-prime with themselves.
Yeah.
Yeah. So a square minus ab plus b square divides 43ab, but since it's co-prime, it divides 43. So it's either 1 or 43. Now, how will you solve a square minus ab plus b square equal to 1?
Then
You can write it as a minus b whole
a
square
plus
is equal
b.
to 1 minus a.
Yeah. So this thing is greater than a minus b whole square, right? It's basically equal to a minus b whole square minus ab, a plus ab. So a minus b whole squared equals 0. Yeah, equals 0. So a equals b. So a equals b and equals 1. Right? And yeah, and if a equals b, then x equals y. And if we just put x equal to y in this equation, we'll get both are 22, right? Because they can't be 0 as well. So 0, 0 is not possible. 22, 22 is a solution. Yeah. And the next case is like a squared minus ab plus b squared equals 43, which equals a minus b whole squared plus ab. So a minus b whole squared is like less than or equals to 6, and ab is also less than equal to 43. So that's a good constraint. And so what can you make? So if a minus b, so if a minus b whole square, if a equals b basically, then you get ab equal to 43. So that's not possible. And if my a minus b equal to 1, then ab equals 42. That is possible. So you get, so if a minus b equals 1, then ab equals 42. It's possible because 6 and 7. So one solution is, so basically 6, 7 and 7, 6 are solutions, right? And if a minus b whole square is 4, then you get ab equal to 39, and that doesn't give any solution. And if a minus b whole square equals 9, then ab equals 34, like 2 and 17, or 1 and 34. So that also doesn't give any solutions, because a minus b is like plus minus 3. So yeah, and then if a minus b whole square equals 16, then again you won't get any solutions, because 43 minus 16, which is 27, ab equal to 27, and then the difference has to be 4, so no solution. So yeah, the only solutions are this, 6, 7 and 7, 6. Yeah, 25 also you can check, I guess. 25 you won't get any solutions. And yeah, I think that's it. You just substitute this thing to get d, and d, I think you should get d. I think you get 1 only. And if you check 6, 7, then it will not satisfy. Yeah. So if you substitute it here, what you get is d. Yeah, what you get is 6 squared minus 6 into 7 plus 7 squared, which is equals to 43. So 43 times d times a plus b, which is 13. So 13d minus 1 equals 43 ab. So 43 into a into b, which is 6, 7. So into 6 into 7. Yeah. So 13d minus 1 equals 42. So d equals 43 by 13. Doesn't give solutions. So yeah, so you reject this case, but it gets rejected. So you just check a minus b whole square. We checked a minus b whole square equals 16 as well. So we just need to check for 25. If it equals 25, then ab will be equal to 20. AB will be equal to 18. So again, no solutions for n.
A is equal to 7 and B is equal to 1 will satisfy.
That I'm coming to that. So a minus b square whole square equal to 36 mein we'll get ab equal to 7. So that obviously will give a solution. So but 7 comma 1 and sorry 7 comma 1 and 1 comma 7 are solution. And if you see, then it won't get rejected as well, because dA plus dB minus 1 equals AB and AB is equal to 7. So dA plus dB equals 7 and yeah, so it doesn't get rejected. So you get D equal to 1. So the only solutions are 1 comma 7, 7 comma 1 and 22 comma 22. So this was like a fairly easy problem. So all you have to do was bound on x squared plus y squared. Bound, first you check the divisor condition by putting the GCD and then you get the bound. Wait, am I audible? Because I think my network is a bit down right now. So yeah, we are done with the problem 2.2. So has anyone tried 3.1 or 3.2? Wait, someone asked. Has anyone tried 3.1 and 3.2? Okay, so what have you tried? Martin and Harsh have tried. So 3.1 is basically like it's a very beautiful problem. It's like a construct. Okay, fine. I won't give a hint. But what do you like? Has anyone solved it completely? Three point one. No. Okay. So this seems impossible to me. Okay, that's a good intuition. But I'll give a hint. The answer is yes. So there does exist a polynomial for every A and B. Like you can construct a polynomial always. But someone asked, do you have any recommendation? Like problem solving? Yeah. So just take a problem from a good contest and then try solving it for a good amount of time, like 1 hour or 45 minutes or something like that. And then if you don't get it, then take a break and try it again. And slowly by experience, you get better and better. So the thing is that you get better at problem solving by getting the good amount of ideas to apply. For example, here in 3.1, the coefficients are similar to like what can you say? Like they are similar to the remainders that you get when you divide by b, like the simple remainders when we divide in Euclidean algorithm. They are similar to that. So, and they're also similar to the base systems of B, right? So you can think about it like that. Doing advanced stuff like that. It depends on which level. So, for example, if you want like RMO or pre-RMO level, then I don't think so. You need such advanced theory, but yeah, at some point you have to learn good amount of theory as well in number theory, because number theory may there are some problems which can be finished by well-known theorems very easily. For example, there's something called Zygmundi's theorem. When you if someone might have heard, so that finishes many problems very easily. So yeah, at some point of time you might have to. Context recommendations. Yeah, I mean these problems are taken from Balkan MO, APMO, ARMO, All Russia Math Olympiad, China TST. All these you can try. Other than those, like you can try the US contests, like there's ELMO, there's USAMO, there's USEMO, and then there is USAJMO. So if you want to go try some easy problems, you can try AIME. AIME has easy problems. So like if you want to do some level between pre-RM and RM, AIME is fine. But then if you want to do problems like better than RMO and INMO, then you should go for USA JMO or USA MO, depending on your level. Like that you have to gauge. ठीक. Chalo, any other doubts or something? So I'll start with 3.1. So like I said, the coefficients as you see them is like the base system, right? Base system B. So B equal to 1 is a dumb case. So for B equal so if I take B greater than equals to 2, there will be a base system, right? And since A is greater than 2B, once again I'll just start writing on the ideas. I just wanted to ask, like, am I audible?
Yes.
Okay, fine. Because I think my video has frozen. Yeah. Anyways, so since A is greater than equal to 2B, we can write A minus B is greater than equals to B, right? And if any number for any number n which is greater than or equals to B, we can write n as k0 plus k1b plus k2b squared plus klb to the L. Where k0, k1, zero, 1, 2 से लेकर b minus. Right? I hope everyone's familiar with the base system and all of that, right? That yeah. But someone sent something on chat. Yeah.
Yes.
Okay. Fine. So yeah. Also, we also know that if polynomial p has integer coefficient, then a minus b divides p of a minus p of b. Also, like p of a minus p. So since we want like p of b to divide p of a, we can set a minus b to be p of b, right? Because if a minus b equals p of b, then p of b divides p of a minus p of b. So p of b divides p of a. So that's what we want. So if it is possible to write p of b as a minus b, then we're done. And that is where we introduce this representation. See, here the good part is that here L has to be greater than 1 because n is greater than equals to b. So there have to be at least like more than one representations. It's not like a constant function, constant polynomial, right? So yeah. So take A minus B so if I take K A minus B to be this, so if I set, so this is basically the, and these K1, K2, KL, K0 to KL are also my coefficients. So I can just set this to be P of B, right? So yeah, I'm done. So this is my polynomial. P of x equals K0 plus K1x plus so on till K to KLB to the L, like Kx to the L. Yeah. So that does exist a polynomial, and here's a construction. So yeah, this is a really special problem because the answer what we expect and the answer, like we all expect the answer to be no, but the answer is yes. So first you are confused whether the answer is no or yes. So what should I prove, no or yes? Because both have a very different approach. And the answer was yes. So you just need to provide a construction. Here's a construction. So Martin liked the problem. Nice. Okay, so now we'll move on to the next problem. So has anyone seen the China TST problem? Achha, by the way, this problem is actually a very recent problem. So if you might be aware of the all Russia MO. So grade 10, third problem, 2023. Yeah. Yeah, has anyone seen problem 3.2? Also, I think some people were trying 3.2 as well. I think Vinayak was trying 3.2. So did you get any good substantial progress, Vinayak?
No, not really.
Not really. Okay, fine. So okay, if I tell you the answer, then I think so the answer is basically AI has to be strictly strictly increasing. So for example, sorry, strictly decreasing. So to get the minimum, and for maximum strictly increasing it will be there. So I'll give you a hint. So anyone wants, then they can complete the solution. So it's a very small hint. So, but it is sufficient to complete the problem. Like just don't get scared because it's China TST, because it's not actually very tough. And it's doable. Matlab, you can think about it. So this is China TST. Actually, it was a China additional TST. Like that's what was written on the forum. And I think it was like 2020. Yeah. P5. So the hint is that if numbers, if A is less than B, if A is less than B and C is less than D, Sorry. Then minimum of A comma C plus minimum of B comma D is greater than or equals to minimum of so like B comma C and A comma D. And why is this useful is because for example A for example n equals 10 for example and A equals and A4 is less than A5, then uh, uh, then the summation will have minimum of A4 comma 7 and A5 comma 9, right? That will be the sum, but that thing is less than or equals to minimum of A5 comma 9 and A4 comma 7. So like that you can get like the constraints. So if A4 is less than A5, then if you switch A4 and A5, you get a better sequence. That is what the idea is. And to prove that, you use this identity. If you just switch those two numbers, A4 and A5, and they don't necessarily have to be adjacent. मतलब A4 and A7 को भी ले सकते हो. So if A4 is less than A7, then if you switch A4 and A7, then you get a better sum, like a more minimum, like a smaller sum. And by better, I mean smaller. So that is why the whole sequence has to be strictly decreasing, or else you can keep getting a better and better sequence. And if you want the maximum of that sum, the sequence has to be strictly increasing. So like that's a basic the proof. So if anyone has any doubts in these two problems, they can ask. So like although it's a China TST, it's like a one-liner, like almost a one-liner. So yeah. Can you explain 3.2 once again? Yeah, sure. Can you re-explain the part where A minus B? Okay, fine. First I'll explain 3.2 again. So what the thing is that, so the summation, if you might have seen the question properly, the summation is ai comma 2i minus 1. Now if you see 2 into 1 minus 1, 2 into 2 minus 1, so on and so on, 2 into n minus 1, this whole thing is like strictly increasing now. So if I have, so यहाँ पर, so the identity which I wrote, the one second, the identity, this identity which I wrote here, if you take C as 2, okay, I'll explain this with an example. For example, suppose n equal to 10. Okay, and and suppose that A4 is less than A7. Sorry, A4 is greater than, yeah, A4 is less than A7. Then I claim that if I switch A4 and A7, then I get a smaller sum. So, but who would have the note? Yeah, Shaurya Agarwal. So did you get the thing? Why?
Yeah.
Okay. Also, yeah, then Vinayak also had asked, no, not Vinayak, what was it? Ayush Banerjee. Can you re-explain the part where A minus B equals and A minus B equals? Okay, so what I've done is basically, see, are you familiar with this thing, like this property that A minus B divides P A minus B if P has integer coefficients? Ayush? Ayush, can you hear me? He's given on chat. Yes. Okay, so he's familiar with this. So since I want PB to divide P, I want P of B to divide P of A, right? So I can have uh like P of B to be A minus B. So if I can have P of B to be A minus B, then I'll be done. You know, because then P of B will divide P of A minus P of B. So P of B will divide P of A. So yeah, and I can set A minus B equal to P of B because A minus B can be written as K0 plus K1B plus K2B square plus K so on so on plus KL into B power L. So if K0, K1 till KL, that is the B representation of A minus B, base B representation, then I'll be done, right? So did you get that? Yeah, okay. So I hope there aren't any doubts in these two problems. So I'll post the advanced problems as well, so you can try them. I don't think we will be able to discuss them because we are short on time, but I'll share the whole PDF thing with you all on OMC, so that you can try them as well. So there are two problems. So we'll start. I'll just share the advanced Is my screen visible right now?
No.
Okay, fine. Just a second. Actually, my laptop is lagging a bit today, so it's again a China DST problem, but I mean it involves a very basic theory, but still it's a very good problem to try. Yeah, has anyone seen this problem? Okay, no one has seen this problem, so I think everyone will enjoy trying it. Sorry. Achha, by the way, here order is not considered, so 2 into 3 and 3 into 2 are taken to be the same. 6 is just 6, then 2 into 3, and f of 6 is just 2. So you can just note the problem now. I'll just stop sharing because it's time. So like if anyone has doubts on the lecture or any other doubts, non-academic doubts, like how to study and or just randomly just they wish to talk with me. So yeah. Yeah, you can stop recording.
Okay.